Okay, so today we're going to be talking about the properties of water. So, a couple of our student objectives for the day. The student will need to be able to identify the five major chemical properties of water. And these properties are high heat capacity, high heat of vaporization, the density of ice, water acting as a universal solvent, and water's high surface tension. So, before we get into that, let's talk about what makes water so important. So, for starters, water is actually the driving force to life existing on Earth to begin with. And without it, our planet would resemble the dusty nothingness of planets like Mars. This is kind of evidence how we haven't found any aliens yet, and we haven't found any life other than humans and like the other life that exists on Earth. And also, like we know this because this is what other planets look like, and we have like images that go close up on these planets to that, so that we know there's no life there. Finally, without it, humans couldn't survive on Earth. Humans are actually made up of 70% water, so without water, we couldn't exist. So, what are the properties that make it so important? Well, for starters, let's talk about some high heat capacity of water. High heat capacity, or rather heat capacity, is defined as the number of heat units needed to raise the temperature of a body by 1 degree. Now, a couple of clarifications in that definition. A body is actually referring to like a body of water, and the number of heat units, the units actually used in chemistry are calories. They aren't the same calories we're used to, as in like the calories we input into our body, but it's similar. Actually, the calories we input into our bodies are actually 1,000 of what we define in chemistry as a calorie. So this is the property that forces water to take such a long time to boil. It's because it has high heat capacity rather than low heat capacity, so it takes like more energy to make it boil. So the key thing to remember here is that heat and temperature are not the same thing. I'll give a quick explanation to that, but it gets a little more complicated, and we'll get to that another day. Heat is kind of the ambient effect that raises temperature, which is kind of showcased by this graphic. Because water has high heat capacity, it heats slower, and this is what allows life to exist in our water, just like these fishes. Okay, so the next property of water we're going to talk about is the high heat of vaporization, and this is very like closely related to the heat capacity, but we'll get to that in just a second. So this is a property of water which allows water to evaporate and turn into a gas, and it's defined as the amount of heat and not temperature needed to make a liquid evaporate. So instead of like the temperature like of boiling water being 212 degrees Fahrenheit or 100 degrees Celsius, we talk about how much energy we actually have to input into the water to make it evaporate. So this is actually the driving force to why our bodies sweat. It's kind of our natural cooling process. This is also why those cooling towers in the background are using it. If they're using this property to actually cool themselves. So it's kind of like when you release gas, you actually are cooled. And this is also a property that forces you to obtain the rolling boil. Like, have you ever cooked a pot of pasta and it just started to like heat off the top a little bit and you thought it was boiled, and then you throw your pasta in and it doesn't actually like work? This is the property that makes that happen. So the next property we're going to talk about is the density of ice. This property of water is actually rather intriguing, and it has a couple of interesting interactions to it. For starters, ice is actually less dense than water, which is caused by the property we'll get to in just a second. But because ice is less dense than water, it actually floats. Kind of like this polar bear. It's so strong it even holds like massive polar bears like that. I'm sure that polar bear actually weighs a bunch of pounds. That poor polar bear. I feel bad for him. But this is caused by the fact that ice actually expands as it freezes. And this is like we know this from a couple of things. Like, have you ever stuck a water bottle or something in the freezer and it actually like busts open, but like you can just see it like this, and it's just like a perfect replica of that? This is because it expands as it freezes. The next property we're going to get to here is water acting as the universal solvent. So water in chemistry is known as the universal solvent because it literally dissolves anything except for organic compounds. Organic compounds are compounds made of carbon. That's why you don't see like you can't like dissolve your desk or something by throwing water on it, because it's made out of carbon and it's organic. But That has its own branch of chemistry, so we don't have to worry about that in this situation because we're talking about inorganic chemistry. So this is also the process that carves out a lot of our landscaping on the Earth. Like, have you ever seen a river like this where it meanders like this? This is actually because the water is flowing. It's like crashing into the wall, and because it like crashes into the wall, it wants to like turn someplace else. So that's what causes these meandering river patterns. Final property we're going to talk about here. We're just going to skim over this one really quick. It's about surface tension, and honestly, this is probably the easiest concept of water to conceptualize. And this is because we've all seen it before. Have you ever done a belly flop in a pool? Surface tension is kind of what causes water to act as like a solid. So that's what causes the pain to happen when you do a belly flop. And because water has high surface tension, it feels almost as hard as if you were on ground when you like impact it at that kind of speed or force. And certain animals can take advantage of this property, and it allows them to do a couple of amazing things. This kind of and one of the examples is this lizard, which can run on water. And this is because it has those big webbed feet, so it's actually slapping the water repeatedly, so the water kind of acts as a solid, and that's what allows it to run on it. All right, so I think that's it. Thank you very much.